Forest fires are becoming increasingly severe across Canada and the world. Currently, forest fires cost the Canadian government around $1 billion to combat and has cost $10 billion in damages while displacing communities. With a huge predicted jump of 200% more forest fires in eastern Canada alone, forest fires will bring a smoky and tragic future.
Introducing Project B.R.E.T.T, the autonomous heat source mapping drone. Built with fire-resistant carbon fiber and powered by NXP electronics, Project B.R.E.T.T comes fully equipped to support firefighters and researchers in the fight against fires. Collecting image and heat data is easy. All you need to do is tell the drone where to go, wait for it to come back, and run a program on the data to create a heat map. Project B.R.E.T.T flies itself because the unpredictable nature of forest fires makes remote-controlled flight at best risky and at worst impossible. Our drone runs the Pix-Hawk 4 autopilot flight stack for autonomous flight control, and waypoints are programmed using Q ground control through a MAVLink protocol. High-resolution images are captured during flight with a 5-megapixel Pi camera connected to a wireless Pi 0 microprocessor on the drone. Images are captured every 2 seconds from takeoff and are stored in an external SD card. Heat data is collected during flight with a Melexis infrared sensor mounted facing downwards on the drone. Custom firmware was created for the drone's flight management unit in order to read temperatures from the sensor 5 times a second and write them to an SD card. Since the images captured by the drone varied in orientation, amount of overlap, and amount of noise, we had to run an image processing program that combined the raw data into a cohesive whole. We used an image stitching algorithm implemented by the OpenCV library in Python to clean up the images. Using the collected temperature and position data, we were able to create a heat map that shows the path of the drone and another heat map to highlight sources of heat. This was accomplished with 2 main Python libraries, the first being matplotlib to create the data frame to graph, as well as Seaborn, which created the heat map. Finally, to complete our image, the photos were sent to another program which overlaid the heat map on top of the stitched image, thus creating our final product. Overall, we are very proud of what we have built in this project. We believe that the autonomous applications of B.R.E.T.T can now allow local governments to respond to wildfire emergencies in a safer, faster, and more data-driven way. In the future, we hope to improve B.R.E.T.T by implementing full integration between the Pi 0 and the FMUK66 controller, and by creating a mobile application for personnel out on fieldwork.
Thanks for watching. We hope you liked our project.